Hello students, and this is working on area between curves. We've already worked with area beneath a line, and you should be familiar with that. The only difference with this is that now we just have a top function and a bottom function, and we're really just finding the area in between this, just like if I was trying to find the area in between these two. Now real quick, I'm going to emphasize how I shaded this because it is kind of important. I shaded it up and down because it's with respect to x. If you haven't guessed, we're going to do some that were respect to y within the next couple weeks or days. And so just kind of take note of this because this is kind of important. Now, something that you should be familiar with, and I'm going to say this over and over again, this is the top function, this is the bottom function, and many times I'll just say top minus bottom, which I'm referring to the f function minus the g function, the top function minus the bottom function, and then the a and b. Since we've already went through a lot of the work with actually solving integrals, you can obviously type these into the calculator. I'm not going to be upset with that, so go ahead and just type them in the calculator. So looking at the homework here, the first problem on MyMathLab, you can see that the function is the blue line on top of the red line. It's not too surprising. Now, they don't give you the intersection points, and I wish they would, but let me go ahead and write out the equation as much as I know here. So it's going to be 5x minus x squared minus 6 dx. Do notice I put in there the parentheses, kind of important, but just use your tools available to you. Let me clean this up here. So if I remember the equations, the first equation was 5x. The second equation was x squared minus 6. And let me zoom out here. Now, whoa. Sorry for that. And so now if you look at this, I can find the intersection points just by clicking in that point and that point. And since this is with respect to x, I just want to go from the left side x value to the right side x value. So in this case, from -1 to 6. The y values won't have any importance on this, so don't worry about them too much there. So going back to this, it'll be from -1 to 6. Now, I'm going to go ahead and just go to my calculator and type it in. So alpha window number 4 there, -1 to 6. The function was 5x minus, and again, I'm going to go ahead and put parentheses in there, x squared minus 6, and with respect to x, hit enter. Now, you can probably guess MyMathLab does not want the answer written as a decimal. I'm going to hope that this changes into a fraction. So what is this? 343 over 6. So if I go back to my answer here, sorry, I got a lot of screens going on here. Type as an exact answer and even using pi, they want that exact answer. So in this case, the fraction is going to be 343 over 6. Check answer, perfect. And again, you just have to kind of memorize like it's the top function minus the bottom function. Just make sure you get the constraints from left to right. Use your graphing tool and it will help you out with everything. All right, let's move on to problem number 3. And I'm going to show a lot of work here, so be aware of this. Okay, let's finish up problem 3, and let me just warn you, this will take quite a bit of work on this. And again, be careful with what's what here. The blue line is the top and the red line is the bottom. And again, I would strongly recommend to you graph it. As you can see, here's the graph. I have purple and black. If you want to, you can actually change these colors to the corresponding. I think that one was red. I think that one was blue, and you can kind of see the top and bottom, see where they intersect. So I know I'm going from pi over 6 to 5 pi over 6. Be careful with this though. All right, let's go back and take a look at the problem. So as I set this up, and again, notice they want this in terms of pi, so they won't accept a decimal answer. A lot of work on this. Take your time. All right, let me go ahead and set up my equation. I'm going to do this one in green. Integral pi over 6 5 pi over 6. 4 sine squared x, that's a square there, minus, oh, let me get rid of that. Cosecant squared x over 4 dx. And again, I'm just taking the top minus the bottom from that constraint from a to b. Now, the antiderivative of this, and if you want more explanation, please say so, and I'll go through that. This is the antiderivative of that one. And actually, cosecant squared is actually a pretty one. The antiderivative of cosecant squared is actually cotangent. It's negative cotangent. I'm sorry, I should make emphasize of that. So negative cotangent x over 4, and I got to figure it out from 5 pi over 6 to pi over 6. So let me scoot this up a little bit. There's a lot of plug and chug, a lot of work that you have to work in here. So plug in 5 pi over 6. I'm going to do the first one in red here. So it's going to be 2 times 5 pi over 6, just like here. I'm going to simplify as I write this out. So it'll be 5 pi over 3 minus sine. Take 2 times that, it'll be 5 pi over 3. You definitely need a unit circle in this. Minus, and then take cotangent, negative cotangent of 5 pi over 6, all divided by 4. It does take quite a bit of work to work this out, so let me see here. That'll be 5 pi over 3. This will become a negative square root of 3 over 2. So since it's negative, it becomes plus square root of 3 over 2 plus, and on the last one here, let me actually get rid of that plus sign. I know there's a lot going on with this problem. Minus, the top here will actually become square root of 3, negative square root of 3. And so the negative and the negative actually just turns this into square root of 3 over 4. That's just the first half of it. All right, let me do the second half with pi over 6. So the second part with pi over 6 is going to be pi over 6 minus sine pi over 6. Oh, I got to take 2 times this. That's right. So 2 times this. This will actually be, oh, dang it. Pi over, oh, dang it. Let me get my blue back in there. Pi over 3 minus negative cotangent pi over 6 divided by 4. Just like I want to check everything there, make sure I have all of my notation correct. Whew. Now, whenever I work this out, it's going to be pi over 3. Oops, that one's going to be negative square root of 3 over 2. And then this will actually become a plus square root of 3 over 4. When you do this cotangent, it's in the first quadrant, so you'll just get square root of 3. That negative will actually make it into a plus. Now I have to take this red expression, subtract it from this blue expression. Let me try to keep that all organized as well. I'll try to keep the red and blue in place as well. So 5 pi over 3 plus square root of 3 over 2 minus square root of 3 over 4. And again, remember I'm subtracting, so I was going to change all these signs here. So negative pi over 3 plus square root of 3 over 2 minus square root of 3 over 4. Combine like terms, find things I can simplify, and there's not much I can simplify here. So let me see, I'm going to combine, I'm going to do this in a different rainbow color. I can combine the pi, oh, let me get rid of that, pi over 3 here. So 5 minus 1 is going to be 4 pi over 3. I can combine these two together. It will become 2 square root of 3 over 2 minus, I can combine those last two, negative square root of 3 over 4. And from this part, I know there's a lot. From this last part, I can combine those because they have the square root of 3, combine these here. So you can think of this as, go ahead and just think of this as 4 over 4, because I got to get a common denominator, and the final answer is 4 pi over 3 plus 1 square root of 3 over 4. And even if you type it in the calculator, I typed it in the calculator quite a few times just to kind of verify. You get like a decimal. I always like to check the decimal just to make sure everything else matches up. This is going to be one of the more challenging problems, so be careful with this. 4 pi over 3 plus square root, won't do the square root of 3 divided by 4, and that should check my answer. I'm sorry, over 2. There it is. And the reason why it's 2, because whenever I subtract this, 4 minus 2, I actually get 2 square roots of 3 over 4, which reduces down to 1/2. Wow. A lot of details. You guys know what the word I say. I say meticulous a lot with this, and this is one you definitely have to be meticulous with. Text me back. Tell me, do you want this on a quiz? Do you not want this on a quiz? Obviously very challenging. Hey, I'm way over the 10-minute limit, so take your time. Don't rush through it. Have a good day.